welcome to another WJEC A level physics question. This was question 1 on the June 2011 Unit 5 paper, and it's a capacitors question. Capacitors are now found in Unit 4. So first part of the question, we've got a parallel plate capacitor with no dielectric between the plates, charged by a cell as shown in the diagram. Well, we've got various bits of data on the diagram. We're asked to find EMF for the cell. Now, the fact they've asked for EMF for the cell confused a few candidates first time round, but basically all they're looking for is the V, the voltage if you like, that caused the capacitor to charge up. Well, we know that the definition of capacitance, C equals Q over V, so V is equal to Q over C. Equation given in a data book just needs to be rearranged. So the charge is 4.7 nanocoulombs. So remember that the charge on the plates of the capacitor, one plate is negative and one plate is positive, but the charge just counts as the 4.7 nanocoulombs, not the total of two lots of 4.7 nanocoulombs. Capacitance is 375 picofarads, pico being times 10 to the minus 12. And if we put those numbers into the calculator, you'll end up with about 12.5 volts, 12.53 recurring volts. Next, we've got to calculate the separation of the plates of the capacitor. So the parallel plate capacitor formula is C is epsilon naught A over D. So D is epsilon naught A over C. So epsilon naught, given in the data book, is 8.85 times 10 to the minus 12. The area is given in the question as 400 centimeters squared. Now, a very common mistake here is to think that you turn centimeters squared into meters squared by dividing by 100, because centimeters to meters is 100. It's a factor of 100. But here it's centimeters squared to meters squared, so we have to square that multiplying factor. So we have to divide by 100 squared, or multiply by 10 to the minus 4 if you like. We're going to divide that by the same capacitance we had in the first part, 375 times 10 to the minus 12. So let's put those into the calculator. And we get ourselves an answer of 9.44 times 10 to the minus 4 meters. Or if you prefer, 0.944 millimeters. Next, the capacitor is discharged through a 15 megaohm resistor, and we've got to calculate the time for the charge on the capacitor to drop from 4.7 nanocoulombs to 0.7 nanocoulombs. So here we have the equation Q equals Q naught e to the minus T over RC. The first step would be to divide both sides by Q naught and then take logs. So we'd have log of Q over Q naught, and it has to be natural logs, is minus T over RC. And a quick bit of rearrangement there, you'll find that T is equal to log of Q over Q naught times RC, and that will be negative because we've got a minus T here. So let's substitute the values into the calculator. So we've got minus log of 0.7 over 4.7. The nanos will cancel, so I'm just going to save myself a little bit of effort there. Times the resistance of 15 megaohms, mega 10 to the 6, times the capacitance of 375 picofarads. So let's put that into the calculator. Get a minute or two. Well, hopefully not that long. And we end up with 0.0107. So about 0.011 seconds, very short amount of time. For the last part of the question, the capacitor is employed as a fog detector and uses the fact that water is a good dielectric. We're going to explain briefly how the capacitor could detect the presence of fog. So the first point is that having a dielectric will increase the capacitance. So let's put that down. They're not asking us here to explain why. It's just simply a fact that we need to know. And then we can finish the question by talking about measuring something that depends on the capacitance. So for example, in the last part of the question, if you increase the capacitance, you can see that the time for this capacitor to discharge would take longer, and that could be measured. So if the capacitor did take longer to discharge, you would know that there was fog present. So let's go for that. So let's just say something like measure the discharge time, which will increase in the presence of fog. You could measure anything basically that depended on the capacitance, maybe the amount of charge stored for a given voltage, or the amount of voltage needed to produce a certain amount of charge. Anything sensible there will do. So thank you very much for listening. Please remember to like and subscribe, and add any questions you like. Goodbye.